Unit 6 Fluid Flow. In the chemical process industries, plants most often handle materials in a fluid state, that is, as a liquid or a gas. In general, fluids are much easier to transfer from one place to another than are solid. Fluids can be transported in pipes in a continuous fashion, whereas solids handling frequently requires rather complicated mechanical conveyors. Science piping makes up so large a part of most process plants that the chemical engineer has to be thoroughly familiar with its design. The sizing of pipes is part of the subject of fluid dynamics, the science concerned with the flow of fluids. Fluid dynamics is also involved in the choice of pumps and compressors, both of which impart pressure energy to the fluid. It is this energy can cause flow. Pumps are used for pressuring liquids and compressors for gases. The most common type of pump used in the process industry is the centrifugal pump. In such a pump, a rotating wheel or disc with fans on it called an impeller is used to impart energy to the liquid. The liquid enters the pump near the center of the impellers, where it is caught by the impellers fans. This impart a velocity to the liquid, and centrifugal force carries it to the wall of the pump, where it exists. The wall or outer part of the pump is called the casing. Although the basic principle of the centrifugal pump is simple, there are many variations of pump design, depending on the kind of liquid to be handled. For example, centrifugal pump may be designed for liquid containing large pieces of solid material such as sewage. Liquid at high temperature, very abrasive material such as suspension of sand in water, or very corrosive liquids such as acid and alkalis. Centrifugal pumps are available in dozens of different materials, although the most common is carbon steel. They are supplied in all of the materials of construction described in Unit 3, as well as other. One of the most desirable characteristics of centrifugal pumps is that they provide a steady flow. Without pulsation of pressure. The second largest class of pump used in process plant is the reciprocating type. All such pumps consist of pistons moving back and forth in cylinders. Reciprocating pumps can easily be designed to reach pressure far higher than those achieved by centrifugal pumps, and this is the area of their most common use. Unlike the centrifugal pump, the reciprocating pump imparts pressure impulse when at each stroke of the pistons. One way of getting around this problem is by using a number of pistons in the pump, each of which reaches the end of its stroke, and consequently its highest pressure. At a different time, the pulsations of such a multiple piston pump that tend to average out so that the pulses are not severe enough to affect most processes. Another use of reciprocating pump is for material liquids. Each stroke of the piston displays the same volume of liquid, so that the output of the pump can be easily calculated. Although any reciprocating pump can be used in this way, some are especially designed for measuring liquids. They are built so that the speed of the pump and stroke distance traveled of the piston are both adjustable. When constructed with several individually adjusted pistons, they are called proportioning pump. The use of proportioning pumps was described in Unit 2. Gas moves in a pipe or duct whenever the intake pressure is higher than the outlet pressure. Pressurization can be accomplished by means of either fans or compressor. Fans are used for flow pressures. Like pump, compressor may be either of the centrifugal or reciprocating variety. The reciprocating compressor is very similar in principle to the reciprocating pump. The common bicycle pump is actually a very simple variety of hand-powered reciprocating compressor. Centrifugal compressors are generally of the turbine variety and are similar in principle to the centrifugal pump, although far more complicated in actual design. In the design and selection of both pump and compressors, the density and viscosity of the fluid to be moved are of particular importance. The density of any material is the mass of a sample defined by its volume. It is usually expressed as grams per cubic centimeter or pounds per cubic foot. This viscosity is somewhat can generally be considered as resistance flow. When poured from a jar, honey flows much more slowly than water. Thus, honey has a higher viscosity or is more viscous than water. But density and viscosity normally decrease with increasing temperature, although the change in viscosity are more pronounced than the density change. Some heavy fuel oils are so viscous at normal temperatures that they cannot be pumped. Consequently, it is necessary to heat them so that the viscosity are reduced sufficiently to allow them to flow. Storage tanks for such fuel oils are equipped with them steam coils for heating purposes. Controlling the flow of liquids in pipes is done by means of valves. There are two basic classes of valves, on or off, and throttling. And on or off valves are the same in place, is either fully open on or fully closed off. A throttling valve may be fully open, partially open, or looking at in another way, partially closed or fully closed. A partially open valves present a resistance that slows down flow, so throttling valves are used to change the rate of flow liquids on or off. Valves are sometimes called stop or block valves because they either permit flow or stop in entirely. The most common variety of valve used in process plant is called a gate valve. It, its gate is a disc of metal that either closes of the pipe or is raised up into the body of the valve so that the opening in the pipe is obstructed. When the gate is in the raised or open position, the body of the valve acts like a part of the pipe and the fluid flow almost as if the valve were not there. It is possible to use a gate valve for throttling by closing the gate only part of the way, but the valve isn't designed for such service and will often be damaged if it is used in this way. The liquid flow tends to wear away the sharp edges of the gate so that it will not close tightly and will leak when used properly. The gate in the open position is withdrawn into the body of the valve so there is nowhere on it from liquid flow. A gate valve is usually opened or closed by turning a handle wheel. In the more common pattern of gate valve, a threaded throat or stem is attached to the gate and is moved by a hand wheel. When the gate is open, the stem projects above the hand wheel and is therefore called a rising stem valves. Rising stem valves are preferred because by looking at the stem, it is easy to see The valves is open-closed when designing a piping system. Space must be provided above the valve so the steam will not hit anything when it rises. If the space cannot be provided, the engineer can specify a nursing steam valve. This can sometimes lead to dangerous situation because an operator may forget that it is a nursing steam valve and assume it is closed because he cannot see the steam. When the valve is actually open, during steam gate valve should be painted or otherwise make it in some distinctive manners. To prevent confusion, gate valves are available for every size of pipe and in a wide variety of construction materials. The valve trim, these moving parts that are made weight by the fluid in the pipe, and frequently made of material that is harder and more corrosion resistant than the remainder of the valve. When it is necessary to control the quality of liquid flowing in a pipe, so throttle it. The most common valve used is the glove valve. To pass through a glove liquid valve, liquid must run through two right angles. This case swirls and aids in the liquid steam which wastes energy. This is contrast to the straight-through flow pattern in a gate valve. This waste of energy in glove valves show up as a pressure drop in the pipeline and in increased pumping costs. Although a glove valve can be used for on or off service without damage, the valve it is normally restricted to trolling service because of its energy losses. Glove valves are usually installed so that the flow is upward around the short of disc. This is to prevent the accumulation of solids that might prevent full closures above the disc. It also permits maintenance to be performed on the upper part of the valve when it is closed but still in the pipeline, because this part is isolated from the high-pressure input side of the line. To facilitate proper installation, glove valves usually have an arrow cast or otherwise marked on the body of the valve. The valve should be installed so that the arrow points in the direction of liquid flow. Glove valve are that the arrow point in the direction of liquid flow. Glove valves are available a wide size range, although very large glove valves are less common than very large gate valves. They are also available there also are available most construction material both for the body, the valve, and for the trim, as described in the preceding unit on instrumentation. Some valves are automatically opened and closed by an instrument rather than by hand. These control valves are generally a variety of glove valve designs. Their most common use is for throttling. A special and rather complex mechanism is needed to accomplish automatic control so these valves are much larger and far more expensive than the common hand-operated varieties. Thank you.